So, are you guys excited? I mean, the stuff that we just heard is so incredibly exciting. The future that we have in front of us in this particular time that we're at in the industry, where institutions are coming on board for real, with real money, where we really are seeing the vision of blockchain coming to fruition with all this on-chain liquidity. But the problem that we have is exactly the problem that Mance and Lehman were talking about, of fragmented liquidity. At one point, we had one chain, it was Bitcoin, and that's all you had to work with. But then a whole bunch of other chains came up. But where we are right now is still just the very beginning. I mean, there's a couple hundred, maybe, public blockchains, but the number of private blockchains that are going to come online is going to be measured in the thousands. And how do you deal with this fragmented liquidity? There's users, there's applications, there's money spread across all of these thousands of chains. Obviously, that's not going to work. And so the solution to this is Clipper that we were talking about. And I'm going to spend some time here to talk about how Clipper works and what makes it a little bit different than the other solutions that we've seen to this point. The deepest, realest difference, the thing that really makes Clipper interesting, is cryptographic proof of state. You may have heard of a state proof, but I'm going to break it down. Fundamentally, we have a ledger, let's call it ledger A, and it's super secure. They've put a lot of effort over the last 10, 15 years to make sure the consensus algorithm is secure. There's lots of participants. It has an active ecosystem. Great. We have a great ledger here, ledger A. And then we have another ledger, ledger B. And it also has done a great job over the last 10, 15 years building its security story, making sure that it's really solid and secure. And then we put a little bridge in between, and the bridge is just a couple of nodes, and it's really not as secure. And this just doesn't seem right. We ought to be able to leverage the security models of both ledger A and ledger B to allow them to talk to each other directly. And the way that we do that is through a thing called state proofs. It's a cryptographic mathematical proof of some information that's in this ledger and some information that's in that ledger, so that they can then verify each other's proofs directly. And through that, they know exactly what messages, what tokens, who the payers are, the application that's sending it. All the information that they need is available to them directly. If you were thinking about it in the Web 2 world, there's some analogy to something like HTTPS, where you get two different servers that are connecting to each other. You can authenticate and authorize who is communicating with you. You know exactly who you're doing business with. And Clipper basically gives us that same capability on a blockchain between any two ledgers. Now, there are no bridges. It's a base level infrastructure. Hashgraph isn't looking at Clipper as like a massive value stream. This is a thing that we want to deploy to the world. We want to increase the flow of liquidity between all of these different ledgers. We want you, like Lehman was saying, to be able to deploy your application to a ledger and have access to all the users and all the liquidity that's on all the other ledgers as well. Because this is the world that we're going to find ourselves in. It's the world that we're in right now, and it's the world that we are going to be in. And all of this happens at the speed of the consensus of these two different ledgers. So if you have two ledgers that are incredibly fast, that have very low latency, you're going to see this cross-chain exchange happen in a fraction of a second. For ledgers that have a longer consensus latency, you'll see it take a little longer for that to occur. But in all cases, it's going to be at the speed of the consensus systems of the two ledgers that are involved. So it's as fast as we can make it possible to do. Now, I'm going to show you a little demo of this working in 4 different scenarios. Before I do, I want to explain a couple things that you're going to see. First, you have your two ledgers, and you want to send some token from one ledger to another. Somebody has to be willing to pay for that transfer. We call that thing, that economic actor, a connector. A connector is just an entity that has basically deposited, they have a smart contract that's running on the two systems, And when you try to send a message, it goes to the connector and says, would you be willing to pay for this transfer? And the connector can say yes, the connector can say no, or the connector could say yes, for 10 cents or however that wants to happen. The connectors are totally permissionless. Anybody can deploy their own connector into the system. So it's not a lock-in at all. This is just pure your choice. If you're writing an application, you may decide to deploy your own connector in both of these places, or you may find a third party who's going to facilitate it for you. But it basically facilitates the payment across the system. So the message is going to end up going from an application to the connector to get authorization to send. At that point, the source ledger is going to create a state proof. That state proof then will be transmitted to the destination ledger, and then a verifier, which is a smart contract on the destination ledger, will verify the state proof to make sure that it's correct. At no point is there any intermediary in the system that you have to trust. You don't trust any sort of a bridge node. You don't even trust the nodes themselves on the two different ledgers. There could be a dishonest node that's sending you stuff. It doesn't matter because you're trusting the cryptographic proof of the ledger itself, not of any one particular participant in the ledger. And that's where the security of this system comes from. And like Lehman said, if you have an ABFT ledgers on both sides, the entirety of the transaction is ABFT, which means that even if you experience a network disruption, it is not going to stop the flow of that transaction from happening. It's all very, very secure and complete throughout the system. So let's go ahead and step into the demo so we can take a look at that. And we'll walk through, like I said, 4 different scenarios. In this first scenario, we're going to be looking at a HashSphere talking to another HashSphere. And both of these could be completely private networks. And the two networks are going to talk directly to each other without any sort of leakage of information into the public world. The other thing that's interesting to note is that when you are communicating from one ledger to another, in that state proof, the only information that's flowing is exactly the information that you need in order to move the value. You're not leaking any of your other internal state. It's all just between you and the next ledger. So this is two HashSpheres talking to each other. The next example that we're going to look at is a HashSphere, which is a private network, talking to the Hedera public network. And in this case, again, even though Hedera is a public network, it doesn't see any of the internal details of what's going on in that HashSphere. You could have all of your clients or customers there. Hedera doesn't see any of that. All it sees is the minimal amount of information that says, hey, I have a message that needs to be sent. It originated from this application, and this is who's going to pay for it. And then on the Hedera side, we can process that in a trusted way. And because both these networks are ABFT, the whole communication is ABFT. All right, so the next example we're going to show doesn't involve a Hedera or a Hyro project at all. It involves another LFDT project, Besu, which a lot of institutions are using for private networks. And we can support that as well. As I mentioned, we're deploying smart contracts to Besu. We can get these systems to pass these messages back and forth, and they can trust each other because of the state proofs that both of them are able to generate. So in this case, we're going from a private network to another private network that had nothing to do with Hyro or Hedera code. And that will work as well. And then the fourth example I'm going to show is another EVM network that's also public, and that would be Avalanche. We can do transfers from a private network to a public network. No, it's not just private to public, by the way. It can go public to private to public, private to private, public to public, any combination that you can think of. We can handle that. Clipper will keep your private details private. You don't have to expose your endpoints to the public internet. If you have a private network, it can all stay private. Your private network makes the outbound connection, and it's able to exchange value with the remote network. So these are all just examples. We've got many more that we can do. Avalanche, doesn't have to be an EVM network. Any network, any ledger that supports state proofs and has smart contracts, we can deploy this to. And that means pretty well everything. Now, Mance mentioned that this is something that we can just do. And you might have thought, well, how? If we have these different networks and they're trying to talk to each other, how do you just make that happen? And the answer is in the fact that we are able to deploy smart contracts to these other systems. And this has a huge effect, as you heard in the previous discussion, for people who want to run on world-class governance with the best performance and low latency and no MEV and no front running and welcome to Hedera, right? You can deploy your application here and have access to all the users that are on all the other ledgers with all the liquidity that's available there. And we're able to connect things from private to private and public to private and so forth, like I mentioned. All of these things are available to us because of Clipper. Now, we are currently open in an early adopter program. If you are interested in exploring this more, in participating in this program, in being a part of this journey of being able to bring this cross-ledger protocol to the world, we have a QR code here that you can go ahead and follow, and you can join. We'll get in contact with you, and we'll be able to work together and make sure that the things that we're developing for Clipper work for you also. Now, I know that I'm between you and lunch. I'm going to give you 2 minutes back so that we can get eating. I appreciate your time. Thank you for being here. I hope this was useful for you and exciting. Thank you.